Alright, in this video we're focusing on Unit 2, representing functions, and we're going to hone in on Level 3, which is analyzing tables. Our math goal is I can identify key features of a table which represents or representing a function. Alright, so the first thing we have to recognize about tables is that tables really, they aren't as informative as a graph is. The table gives us an incomplete picture of the function. Because they only can give us a few points here or there. Where a graph, it's an infinite number of points, okay? So we really have to make a good guess about what the function is doing. You can think of a table as a snapshot. So it kind of shows us what the function is doing at specific times, but we fill in the blank. So imagine you doing a snap or something on Snapchat. You're taking a snap of time, like an event happening right then, but we don't know all the details. You know what I'm saying? You can only give us a piece at a time. That's kind of how a table works. But we have to assume that the table represents a continuous function, which means it's going to keep going, a pretty smooth function, okay, with no weird breaks or weird things happening. So we'll get into it and you'll see more of what I'm talking about. So our key features are not going to change. We're still going to define the x-intercept and the y-intercept. Remember, the x-intercept is the value of f of x when x equals 0. And the y-intercept is the value of x when f of x equals 0. So when we have a table, we're looking for just that. The x-intercept is when oh no, that should be when f of x equals 0. Dang. That's so wrong. In this video, we're going to cover Unit 2, Introduction to Functions, and our focus is Concept 3, Analyzing Tables and Graphs of Functions. We'll begin with Level 2, which is Analyzing Graphs, and our math goal is I can identify key features of a graph which represents a function. We have a lot of vocab coming at us today, so you want to have your pencils ready to take notes, okay? All right, so the first key features we'll go over is the intercepts. This is the x-intercept and the y-intercept. The x-intercept is the value of x when f of x equals 0. Remember, f of x is what? The same thing as y. It's your output. Okay, so the x-intercept is the x when the output is 0. And the y-intercept is the value of f of x, or y, when x is 0. So how does this look on a graph? The x-intercept is where the graph crosses the, surprise, surprise, the x-axis, right? So it's where the graph and the x-axis intersect. That's why we call it the intercept, x-intercept. The y-intercept is where the graph crosses the y-axis. Okay? Our next feature should sound familiar, which is domain and range. Remember, domain is a set of all input values of a function, and the range is a set of all the output values of a function. So here's our graph. How do we find the domain of the graph? Remember, we're going to look left and right, because we're looking along the x-axis, and we're going to ask ourselves, what's the leftmost point of the graph? What's the rightmost point? We can tell that this graph is going to continue in this pattern. So is there a leftmost point? No. Is there a rightmost point? No. So our domain is going to be all real numbers, or from negative infinity to positive infinity. And then when we look at the range, remember we're looking from the lowest to the highest. So we're going to start with the lowest, how low the function can go, which is -4 until +4, and that's our range. The next feature we'll focus on is when the graph, or when the function is positive and when the function is negative. The function is positive when f of x is greater than 0. And the function is negative when f of x is less than 0. Let's jump right into an example. So here we have a graph of a function. We can see here where the blue is, all of this is where the function is positive. These are the places on the graph where the graph is literally above the x-axis, right? And the negative part of the function is when the graph is below the x-axis. So all of this right here is where the function is negative. All right, what about the next one? The next one is increasing and decreasing. So what is increasing? Increasing means to go up, right? So we're looking as x increases. So as x goes up, f of x goes up. That's how we know the function is increasing. For decreasing, as x increases, f of x decreases. So let's take a look at the graph. So take a look. Here, if I look from left to right, it's very important that you look left to right, left to right. The graph goes up, so this is increasing, and then it also goes up here. That's increasing. Where is it decreasing? When the graph goes down. So here's where the graph is decreasing, or when the function is decreasing. Next, we'll focus on maximums and minimums. These remind me of roller coasters. So here, take a look. The relative or local maximum is the point on the graph where the graph changes from increasing to decreasing. So my graph was going up and then it started going down. This point up here is your relative maximum. Your relative or local minimum is when the graph does the opposite. It's decreasing and then it switched to increasing. So it was going down, then all of a sudden it started going up. This point right here where that change happens is your minimum. So here's a look at it again. The graph is increasing, then it starts decreasing. So that's why we have a maximum here. And then for a minimum, it was decreasing, then it started increasing. That's what gives us a minimum. Why do we call it a local minimum or a relative minimum? Because when you think of maximum, you think of the highest point, right? Well, this point is pretty high, but is it the highest point on the graph? No, because we can tell this thing is going to keep on increasing. That function is going to keep on increasing. So this is not the maximum point of the function, but it's relative. It's a local maximum. In this area, it's the highest point on the graph, okay? Same thing with the minimum. This is a low point, but it's not the lowest point. That's why we say relative or local maximum or minimums. Lastly is the left end behavior and the right end behavior. Left end behavior describes what the function is doing or is going to do as x continues to decrease. So as x goes down, what is f of x doing? That's what the left end behavior gives the answer to. And for right end behavior, it's the opposite. As x increases, what is f of x doing? All right, so let's take a look. So for left end behavior, as x decreases, as we look to the left, we can tell that f of x is doing what? Is decreasing. And for right end behavior, as x gets bigger, 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 what is f of x doing? F of x is also increasing. So that's your left and right end behavior.